Okay, so let's derive the law of cosines. So the law of cosines says that if we have a triangle with sides A, B, and C, and an angle theta between the sides of length A and B, then the side C squared equals A squared plus B squared minus 2AB times the cosine of the angle between them. Okay, so the way we're going to go about this is we're going to use the Pythagorean theorem. So assuming that the Pythagorean theorem is a theorem we already have, right, because this looks very similar to the Pythagorean theorem, except that it needs to be modified by changing this from a 90-degree angle to some angle theta, if that makes sense. So instead of, if theta was 90 degrees, then this would reduce to the Pythagorean theorem. We wouldn't need this extra term, we would just have c squared equals a squared plus b squared. So we need to adjust for having an angle other than 90 degrees. So what we can do is break this into two 90-degree triangles. And so what we're going to do is we're going to solve for c squared in this triangle on the right. So let's start to label some things. So let's call this side D, and then that will make this B minus D. And if we relabel that, B is going to be the whole side. And let's call this height H. And to keep things as simple as possible, meaning don't introduce additional variables we don't need, we know that the sine of theta is going to be h over a, right, opposite over hypotenuse, and so h is a sine theta. Okay, and so now we're going to write two equations, so one for each of these right triangles. So for the left one, we have b minus d squared plus the height squared, but we'll just write the square of a sine theta, which is going to square both a and sine of theta. That should equal a squared. And then our other equation, which will give us c squared, is d squared plus our height squared, which is a squared sine squared theta. So basically what we want to do is we want to find d squared plus a squared sine squared theta. If we can find that quantity on the right here in the second equation, then we can find c squared. So let's find what d is from the first equation. So instead of expanding this, we're going to solve for d first, because if we expand this, we're going to get two terms for d, and we want to have only one. So if we solve for b minus d squared first, it's going to be a squared minus a squared sine squared theta, which we can factor out a squared. And we know that 1 minus sine squared theta is actually cosine squared theta. And that's from the Pythagorean identity. It's a pretty quick derivation, but I'll do that in a separate video. And so now let's find b minus d by square rooting both sides. And we don't have to worry about plus or minus because side lengths can only be positive. Okay, so then solving for d, that's going to be b minus a cosine theta. Okay, but we want d squared. So d squared is, so when we square this expression and FOIL it out, we have b squared minus 2ab cosine theta. So you can see where that term's going to come in. And then plus a squared cosine squared theta. And what we want to solve for in order to get c squared, we want d squared plus a squared sine squared theta. So we're just going to add a squared sine squared theta to this expression. And from here, we see that we can factor out a squared. And I'm just going to reverse the order of sine squared and cosine squared so that it appears like it typically does in the Pythagorean identity, where we know that sine squared plus cosine squared is 1. And so, because we know that d squared plus a squared sine theta is equal to c squared, and we've gotten 1 here, then let's just rearrange the terms. We have a squared times 1, right, plus b squared minus 2ab cosine theta. Alright, and that's it. Let me know what else you'd like to prove. Thanks for watching.